In this lecture, we'll learn about the smallest and largest newborn stars and what's typical for a newborn star in our galaxy. There's a lower limit and an upper limit to the masses of newborn stars. First, we'll take a look at low-mass stars. Contracting clouds with masses that are too low never become stars because their central temperatures can't get above the required 10 million Kelvin threshold for fusion. This is because of a type of pressure called degeneracy pressure. It halts gravitational contraction before hydrogen fusion can begin. Up until now, we've been talking about regular old thermal pressure. As you heat something up, its thermal pressure increases. Degeneracy pressure is different. It depends only on density, not temperature. Degeneracy pressure arises from the rules of quantum mechanics that prevent subatomic particles like electrons from getting too close together. Under most circumstances, the restrictions on particle spacing have little effect on the motions or the locations of electrons. But if a protostar has a mass below 0.08 solar masses, the electrons become packed closely enough for the restrictions to matter. These protostars are too small, and there's not enough room for all the electrons. Degeneracy pressure halts the contraction, and the core never becomes hot enough for fusion. The result is a failed star known as a brown dwarf. Brown dwarfs are faint and difficult to detect, but since they are still relatively warm, looking for them in the infrared allows us to see them. The maximum mass of a star is not as well defined as the minimum mass. We've seen stars with masses greater than 100 solar masses, but none definitively above 200 solar masses. Theoretical stellar models suggest that radiation pressure limits how massive a star can be without blowing itself apart. Radiation pressure is yet another form of pressure. It's caused by light. The maximum mass for a star is thought to be around 150 solar masses, but new observations of stars in a neighboring galaxy suggest this number could go somewhat higher. In summary, stars less massive than 0.08 solar masses can't sustain fusion, and stars more massive than 150 solar masses are likely to blow apart. What then is typical for the mass of a newborn star? Observations of star clusters show that star formation makes many more low-mass stars than high-mass stars. This schematic shows how many stars of each mass are produced for every star greater than 10 solar masses. What we see is that very massive stars are relatively rare. Lower mass stars are common. Okay, that's all for Chapter 16. And now you know how stars are born.